Okay. So, we have been considering convolution. Okay. Now, consider a system this is the linear rate shift invariant system and therefore, is characterized by its unit sample response. So, that for any input x n, output will be a convolution between x and h or equivalently h and x, this is given. Now, that means y n is x n convolved with h n, but as I told you, I always prefer the other form, because then results become easier to get. So, this is a rule of thumb I told you. So, I follow this, and this is nothing but if you write h or next guy comes, I want to find out y at particular n. So, n is fixed, that n I put, but r will come with a minus, first guy here, second guy here, and r will be a local index, right. This if you expand for r, see the summation is from minus infinity to infinity. I divide it into two range, r equal to 0, 1, 2 up to plus infinity, and r equal to minus 1, minus 2, minus 3 up to minus infinity. So, one term is from r equal to 0 onwards, this h 0 x n, h 1 x n minus 1, h 2 x n minus 2. And then r minus 1, h minus 1, x n plus 1. Dot 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 dot. Now, suppose x n is really obtained by sampling an analog signal. So, there was a time sequence x 0, x 1, and this was 0, this was t, x 2, there is 2 t. We wrote in the form of sequence. So, it was just index 0, index 1, index 2 like that, but actually it is like this in real time. That means, x n will be the sample at n t, that is my current time. I am standing at this sampling point, this is my current, because I want to find out the current output. So, n is the current index, n t is the current time point. I have to find out output at current time point, that is n into t, or current index n. Now, n minus 1 will mean 1 t backward. So, n minus 1 into t. So, that is past. So, you see here in this summation x n, that is the current index output, that is already known, that is the current input. X n minus 1, that means in terms of time n minus 1 into t. So, it is the past, one sampling period ago it came. So, that is already known, because it is in the past. X n minus 2. So, it is a past index in terms of time n minus 2 into t, that is current index is n t, n minus 2 into t means 2 t before. So, 2 t amount of time ago that sample came. So, these are known information. So, computing this is no problem, this part is fine, but look at here n plus 1. You are going to this right hand side, n plus 1 into t, but you are standing here, this is my current time. At current time, I have no idea about what the future sample will be. So, in real time operations, this is not known to me, because I am standing at current time index, that is time point is n into t, index is n. At that time, I have no idea about what my future sample will be at n plus 1 into t, that time point, or index n plus 1. Same for this, same for everyone. So, for real time operations, this is not realizable, right. Therefore, in order to make the system realizable and practical and deterministic and all that, this part must vanish. Only way you can do that is by choosing the system impulse response, unit sample response, so that this value equal to 0. So, 0 into this is 0, this value equal to 0. So, that 0 into this is 0, and you add so on and so forth. So, this second term, this second expression does not arise. Okay. A system where current output depends only on the current input, and past inputs is called a causal system. If it depends on both past and future inputs, then it is called non-causal. And in a special case where current output depends on only future inputs, it is called anti-causal. Obviously, for our real time operation we want causal. So, for causal system, that is for causality, we should have h minus 1 0, h minus 2 0, we should design the system so that these coefficients of the unit sample response are 0. That is, causality implies H r equal to 0 for r equal to minus 1, minus 2 dot 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 dot. This is causality. UN is causal because for n less than 0 all values are 0, for n 0 and onwards 1. So, if UN is the unit sample response of a system linear simple invariant system, I am happy that system will be causal. Okay. How about UN minus 1? It will be shifted to the right by 1. So, this 0, this 1 will move here, this one will move here, next one will move here. So, it will be 1 1 like that, but this 0 will move here. So, this will be 0, this will be 0, this will be 0. Again it will be causal, there is no problem, because this is 0 to the left of origin. I want this to be 0 to the left of origin. So, this is 0 here, 0 here, 0 here, 0 here. Okay. So, it is causal. This 0 does not matter, only consideration is for minus 1, n minus 1, n minus 2, n minus 3 like that, it should be 0. But how about u n plus 1? Here it is advanced, shifted by minus 1. So, this one will come to the left, this one will come to the left, this one will come to. So, I will have 1, 1, 1, 1, 1 dot 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 and 0. This will, if this be the unit sample response of a system, then that system is non-causal, because apart from these samples I have got one fellow to the left of origin. So, it will make it non-causal. All right. Any impulse response, any h n, if you multiply by u n, it will be causal, because u n makes sure that on the right hand side samples of h n they are multiplied by 1. So, they are as it is, left hand side samples are of these are multiplied by 0. So, they become zeros. So, often to indicate causal systems, we write like this into u n, like 2 to the power n u n. So, if 2 to the power u n is not present, you will have its value for 2 to the power positive n, for positive negative n also. 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power minus 1, 2 to the power minus 2. So, both for negative n and positive n you will have values that will correspond to, if that is h n, that will correspond to a, if this is just 2 to the power n, no u n, it will correspond to a non-causal system. But the moment I multiplied by u n, values of this 2 to the power n will be considered only for positive n, because then u n is 1, 1, 1, 1. So, the value will be multiplied by 1, you will get as it is. So, 2 to the power 0, it will be 1, 2 to the power 1, it will be 2, 2 to the power 2, it will be 4 as it is, because they are multiplied by 1 from u n, no change. On the left hand side, whatever be the value, that will be multiplied by 0, because u n is 0 to the left of the origin. So, 0, 0, 0, 0, 0. So, it is a causal system again. All right. So, causality is very important for real time operation. You should design a system, all the digital filters we design, we ensure that they remain causal. Another related concept, very useful concept, is stability. Stability means, very roughly speaking, we have seen what is a convolution. We have seen convolution Just a minute. I am not finding it here. So, you have seen convolution is a summation, like y n, when I write say h r, sorry, x n minus r. So, it is like an infinite sum, h 0 x n, h 1 x n minus 1, h minus 1 x n plus 1, dot 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 is infinite sum. So, what happens? There is a danger that even if you give an x n as input where every sample is small, is finite valued, this is an infinite sum. So, magnitude of the sum shoot up to infinity. If that happens, then that output is no good. In fact, it cannot shoot up to infinity. Whatever is the power supply, it will latch on to that. Okay, so it will not be a meaningful response of the system to the input. I will see just a line. So, there is an inherent danger in these infinite convolutions, because it is infinite summation. If that happens, I say system is not stable. Rather, by stable system, I want output to be meaningful response of x n, that should be finite. So, I can see this much it is. So, it is a response of the system to input x n. But if it shoots up to infinity and therefore held up at some supply value, it carries no information for me, it is no good. So, I do not want that to happen, but that can happen because convolution has an infinite summation, sometimes it can shoot up to infinity. So, that I have to avoid. So, I have got y n, and this is a linear shift invariant system again. So, it is characterized by h n. So, y n is either x convolved with h or h convolved with x. As I told you, I always prefer this. So, mod value, it could be positive or negative, or it could be a complex number. Sequence not only does not have to be real valued sequence, x n can be a complex valued sequence, h n can be complex valued. All right. So, mod of this means mod of this summation. But there is a triangle inequality, that is mod of two numbers, in general complex, but they could be real. Mod of z 1 plus z 2 is less than equal to mod of z 1 plus mod of z 2, which follows very easily, because any number complex in general, say maybe z 1 and another z 2. This is by vector sum z 1 plus z 2. Mod of z 1 is this length, mod of z 2 is this length, and mod of z 1 plus z 2 is this length. We know triangle's property, that summation of two sides of a triangle is greater than the length, summation of the length of, sum of the length of two sides of a triangle is greater than the length of the third side. Okay, so, it is greater than, it can be equal if they are collinear and pointing in the same direction, z 1 and z 2 pointing in the same direction. So, overall is z 1 plus z 2. So, in this case length of z 1 plus z 2 is same as length of z 1 plus length of z 2. That is why it is greater, less than or equal to. By triangle law, it is strictly less than when they are not collinear, but if they are collinear and pointing in same direction, this is equal to. So, what we have here, so you can generalize it. If I have got z 1 plus z 2 plus z 3, it is less than equal to mod, you can take these two together first, plus z 3, then again you can take this like that. So, this way you can build up. Mod of summation is less than equal to summation of mods. So, there is a summation and mod, so that is less than equal to summation over mod. But again, two numbers in general complex could be real also. Mod of this is same as mod of Z1 into mod of Z2. Why? Very simple, you write in polar form. Whenever product of numbers come, complex numbers in general, you choose polar form. That is, Z1 is some R1 e to the power j theta 1, Z2 R2 e to the power j theta 2. Whenever product comes, whenever addition comes, choose the rectangular form, a plus jb kind of form for representing a complex number. Complex number because there is a more general number, real is part of it. Now, Z1, Z2 if you do, it will be R1, R2 and e to the power some j theta 1 plus theta 2. So, mod of that will be R1, R2, the magnitude part. But R1 is mod Z1, R2 is R1 is mod Z1, R2 is mod Z2. So, this is satisfied. Therefore, mod of the product is same as product of the mod. All right. Now, what we are given is that every input sample is finite. That is, any x, maybe any x L, L can be any index, n or n minus r, any index. Its mod value lies within some range. Mod value magnitude lies within some range, within a bound. Mod is positive, so it lies within a bound which is finite, less than infinity. Okay. Maybe you can put less than equal to. So, that means x of L for any L, any index, not only one sample, L sample, for any L, this is given to us, given that every sample has magnitude within some range, that mod of the magnitude is bounded. Magnitude is always positive or 0, if the number is 0, its mod is 0. So, 0 to some positive, but maximally it can be capital M, not more than that. That means, if you take out the mod, it can go in the positive direction as M, negative direction as minus M, and where M is a positive number less than infinity. If this is given, that is I am not giving you bad input, I am giving you input, well behaved practical input lying within some range. So, that means, this fellow is for any index, you can even imagine n minus r to be L. So, this is less than equal to M, because there is a mod. So, M, so this summation M will go out for any index, r is varying, so index is varying, but mod is less than equal to M. So, this summation will be further less than equal to M will go out summation mod HR, this fellow will be, this is summation everybody less than equal to M. So, M I goes out of the summation as common, summation of mod HR remains, this is further less than equal to this. Okay. Now, I want this person not to shoot up to infinity. So, if I ensure that this side does not shoot up to infinity and M is finite, that means, if this summation which is an infinite summation, though there is a risk that it might shoot up to infinity. If I somehow make sure that this summation of positive or non-negative numbers, because it is mod, this summation does not shoot up to infinity. So, there is some, it remains finite. So, finite into finite, left hand side less than equal to finite means left hand side is finite. So, then I will call the system is stable, bounded input, bounded output, BO stable, BIBO, bounded input, bounded output. All right. So, that means there is a condition, there is absolute value of every sample of the sequence Hn, every sample, and summed over all the samples. So, absolute thing should be summable, that is when you sum you should get a finite number. So, it is summable because it is finite. Okay. If this is satisfied, if this is finite and this is finite, product is finite, then it is guaranteed mod y n also will be finite, it will not shoot up to infinity. But this is a sufficient condition. Okay. Sufficient condition, because if this happens, then this will be finite definitely. But if this is infinity, it does not necessarily mean this also will be infinity. This can still be finite, and finite is less than equal to infinity. So, that still may be satisfied. So, if the right hand side is finite, I am pretty sanguine that left hand side will be finite. Okay. So, it is a sufficient condition. If this happens, it is sufficient, that will be finite. But it is not a necessary condition, that if this must happen, then only this will be finite, mod y n will be finite, because even if this does not happen, if this is the right hand side, that is this summation shoots up to infinity, still in some cases mod y n can be finite, because still then even then this less than equal to will be satisfied, finite left hand side, infinite right hand side. So, left hand side is less than equal to right hand side. So, it is a sufficient condition, but not necessary condition. Nevertheless, to be always on the safe side, we try to enforce this sufficient condition in our filter designs and other processes. Okay. Now, as an example, if I give you a sequence half to the power n u n, if I give half to the power n just, then you see it will be non-causal, it will go on both sides. So, half to the power 0 is 1, then half to the power 1 is half, then half to the power 2 is 1/4, like that, but half to the power minus 1 is 2, half to the power minus 2 is 4. So, 1, 2, 4, half, 1/4, like that. So, all positive numbers. If I add their mod values, mod is same as this because all are positive. You see it is dying out on this side, but it is growing on left hand side. So, if you add all of them, summation will not converge, it will diverge, it is going to infinity, which means this condition will not be satisfied. So, it will not be Bibo stable. All right. On the other hand, if I give you half to the power n u n, then there is no problem. It will be 1, it will go on the right hand side, it will be causal also, because left hand side is 0, dot 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 dot. So, 1 half 1/4 dot 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 dot. So, if you take the mod value, that is these values only, because they are positive, and add, it will be this dot dot dot, and you know what this sum is, it converges to 1/1 minus half, which is 2, which is a finite number. So, in this case it will be Bibo stable. So, we want to enforce systems which are both, we want to design systems which are both causal and stable for real life operations. All right. Okay. Next is convolution, how to carry out convolution graphical or manual. Okay. You remember convolution means, say maybe y n is given to be h n x n, convolve with x n, or vice versa. Okay. And both the sequences are given to you how to carry out convolution. So, you can write either as h convolve with x or x convolve with h. Suppose you write like this. So, h r x n minus r. This you have to find out. Sometimes you can do it graphically very easily. Suppose you are given two sequences x n as this, 4, 2, 1. And H is given as is a non-causal sequence. At -1, it is 2, okay. Then at 0 it is 1, and at 1 again 2. You have to convolve them. Now, to convolve them, first thing is I have got HR. So, instead of writing as HN, you write it as HR. As R. This is 1, 2, 2. X n minus R you have, right? X n minus R in this summation I can write as x minus R minus n. N is your choice, n you have fixed up, you want to find out the convolution at a particular n. So, this n is constant. So, like H, x also I write as a function of R. Okay. Then I write it 4, 2, 1 as a function of R. But here I have got x minus some index. So, you write x minus R. This will be interesting. What is x minus R? If you are confused, you give it a name GR. GR is x minus R. So, you are plotting GR versus R. So, what is G0? G0 means x minus 0, x minus 0 is same as x0. So, G0 is x0, no problem. X0 is 4, so G0 remains 4. What is G1? G1 is x minus 1, but x minus 1 was 0. So, this is 0. What is G2? X minus 2, x minus 2 here 0 value. So, 0 and so on and so forth zeros. What is G minus 1? G minus 1 means x minus minus 1, so x plus 1. X plus 1 was 2. So, G minus 1 at this point minus 1, it is 2. What is G minus 2? X minus minus 2, that is x 2, and x 2 is 1. At point number 2, it is 1. So, this will go become 1. And then G minus 3, x minus minus plus, so x 3. X plus 3 is 0, so it will be 0 and 0 onwards. This is your x minus R. All right. I want to carry out this convolution at various points. Okay, I want to carry out this convolution at various points. N equal to 0 and find out, n equal to 1, n equal to 2, dot 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 dot. Okay. If I do it, start with n equal, then n equal to minus 1, n equal to minus 2, like that. Start with n equal to 0. N equal to 0 means this will be, if you write x n minus r is x minus of or minus n, that means g of or minus n, because what is gr? Gr is x minus r. G of L x minus L, G of k x minus k, that is x minus k g k, x minus r g r, x minus m g m, x minus some index g of that index. So, x minus r minus n means g of r minus n. So, I can write this as g r minus n. okay, and R is varying as before. All right. So, now we have to find out say this convolution at to start with at n equal to 0. So, H r G r you have to multiply. What is G r? This. Okay. So, H r into G r for every r equal to 0, r equal to 1, r equal to 2, r equal to minus 1, like that I have to find out. Multiply and add. So, H 0, this guy G 0, this is G r, G 0, we multiply. We get 1 into 4. Then I have 0 here, non-zero. So, product is 0. Okay. Sorry. Yeah, product is 0. This side is 0. So, 0 into 1, 0 into this fellow, but that is 0. Next is 0 into whatever 0. So, right hand side nothing. I have to carry out the summation for all the r's. I have to do this sample wise product h into g, h of some r and g of some r, because I am taking n equal to 0 case. So, h r g r. So, g r is this waveform, and I will do sample wise multiplication. R equal to 0, multiply this with this, r equal to 1, multiply this with this, r equal to 2, multiply this with this, r equal to minus 1, multiply this with this, and then add. So, you see only two terms are coming, this 4 into 1, so 4, and this 2 into 2, another 4. Here I have got minus 1, but here I have got 0. So, result is 0. Then zeros here, they do not contribute anything. On the right hand side I have got all zeros. So, they multiply the samples from here, non-zero and other zeros, they do not contribute anything. So, only this into this plus this into this. So, I have got 4 into 1, 2 into 2, 4 plus 4, 8. Okay, so, output will be 8. So, similarly, we can carry out the other one. I mean, I will continue with this exercise in the next half. Thank you.